Hello students, we were just solving the questions, right? So here we got another 5 sets of 5 questions. So just see the first question. State law of conservation of angular momentum. If the particle moves in circular path with decreasing speed, how its angular momentum changes? So this is the question, first question. That is, first you want to first you want to state, not find out, state. State means you want to just surely state the law of conservation of angular momentum. So here you want to show that thing. So you know that this angular momentum all comes in circular motions, right? Whenever there is a circular motion, then only this angular momentum, torque, this type of things will come there. You all well know all these things. So in the linear type of motions, you know that from Newton's second law, what is that? dp by dt is equal to F external force, right? So this is a Newton's second law. So with respect to this thing, there is an analogy to the circular motion. Analogy means what? Similarity. So instead of P where P is a linear momentum, in a circular motion, this P will be analogous to angular momentum which is given by L. And F, instead of F, what will be coming? So analogous to F external will be torque. Okay. So here the similar equation can be written in the circular motion also. So how it will come? That is dl by dt will be equal to tau external. That means differentiation of angular momentum will be giving you which quantity? The external torque. So this is another way, another expression of Newton's second law in the circular motion or circular type of motion. So here, if tau external is equal to 0, that means if just consider that there is no torque acting on the system, then the above equation, that is equation 1, will become what? Dou L by dl by dt is equal to 0. You know one thing, that is differentiation of anything will be 0. Then that particular quantity will be what? A constant. That means d by dt of a constant will be equal to what? 0. That means from the above equation, L will be what? L means what? Angular momentum will be equal to a constant. So here the law of conservation of angular momentum states that the angular momentum of a system will be conserved if there is no external torque acting on it. That means if there is no external torque acting on in system, then the angular momentum will be conserved. In the case of a planetary motion and all, your angular momentum is conserved. Why? Because there is no external torque acting on the system. Got it? So this is about the first question, first sub question, answer of first sub question of the first one. Now B, the first question, B session. If a particle moves in circular path with decreasing speed, how its angular momentum changes? B, that means if a particle moves in a circular path, with decreasing speed, that means your velocity is there which is decreasing. Your velocity is decreasing there. Okay. Now, how its angular momentum changes? This is the question. So you all know that angular momentum is equal to what? R cross P. P is a linear momentum. So R cross P, or otherwise R cross mv. P is equal to linear momentum, which is given by mass into velocity. Right, more precisely, I will just write mvr. L is equal to mvr. Okay, so I'm not taking the cross product and in a correct way. I'm just writing okay mvr. Okay, now it is clearly said that your velocity is decreasing, and especially note that for the exam don't put this arrow for the convenience. For a fast revision we are using these type of symbols. Then obviously if v is decreasing, then obviously your L will also decrease. Now the next question is that whether the direction changes. You itself say whether the direction changes. In the circular motion, R cross P, P is along the tangent. So when right hand thumb rule, your thumb will denote what? The direction of the angular momentum. That means even if the velocity changes, the direction won't change. That means your angular momentum will also decrease in the same direction without change in direction. Without change in direction. This is the thing. Understood? So this is the first question. Okay. So we are just going to deal with just pause the video, or you just go through that thing and just understand the things very fast. Okay. So I hope you understood the first question. Now state first law of thermodynamics. B. An electric heater supplies heat to a system at rate of 100 joules per second. If the system performs work at a rate of 75 joules per second, calculate the internal energy increased. So this is a question. Two sub questions are there. First one, state first law of thermodynamics. So what is the first law of thermodynamics? So first law of thermodynamics states that in a system, if you have a system there of gas, then if you are supplying some heat, it means Q or delta Q, a small heat, then obviously this gas molecule will start to move fast or in random position, right? There, this heat supplied will be utilized for the change in internal energy and the work done by the system. That means the heat supplied to a system will be utilized for its change in internal energy as well as the work done, a system. So this particular idea is the actual basis of the first law of thermodynamics. So delta Q is equal to delta U plus W. This is the first law of thermodynamics. And the second sub question. So this is the first question, sub question. Second one, an electric heater supplies heat to a system at a rate of 100 joules per second. That means electric heater supplies heat to a system. That means Q, or there delta Q is equal to what? At 100 joules per second. That means per second it is giving 100 joules. So that 100 joules is the amount of heat given. Don't think that joules per second. I'm saying that per second 100 joules. That's why I have just given that particular unit. Okay. So here 100 joules is the amount of heat given. So delta Q is equal to 100 joules. Now if the system performs a work at a rate, if system is working at a rate of 75 joules per second. So we are just taking in a second. What is the thing? So in a second it is doing a work of 75 joules. So you want to find out the change in internal energy there. So from the first equation, this is the equation for first law of thermodynamics, equation 1. So we are substituting those things. So delta Q is equal to delta U plus W, and from there delta Q is equal to 100 is equal to delta U plus 75. So from there delta U is equal to what? 100 minus 75, that is equal to 25 joules. So this is the thing. So internal energy, delta U is the internal energy, and that is equal to 25 joules. So the heat supplied, or heat given to a system, is utilized for its change in internal energy as well as the work done, or doing work by the system. So this denotes the first law of thermodynamics, and numericals is given like this. So you got an answer, that is delta U is equal to 25 joules. So this is about the second question. Now coming to the third question. If a particle executes SHM, what do you mean by SHM? Simple harmonic motion. Simple harmonic motion of a amplitude A. First sub question, at what distance from the mean position its kinetic energy equals its potential energy? At what distance from the mean position is its kinetic energy equals to its potential energy? Second sub question, at what point is its speed half the maximum speed? So this is a very important question and a bit difficult also, because you want to by heart certain things, equations. If you know the equations easily, you can do the thing. Otherwise you want to derive those things and you want to get into a conclusion. Okay, so we are just directly moving on to the answer. At what distance, first sub question, at what distance from the mean position? So first clue is given, that is kinetic energy is equal to potential energy. So from there we can just directly write kinetic energy is equal to, and for a simple harmonic motion, is equal to half k a square minus y square is equal to potential energy half k y square, half k y square. This is the equation. Just go through that chapter and you will get these particular equations. So half k a square minus y square, that is equal to half k y square. From there half cancel, and from there you just do the things and you will get to a conclusion. K cancel, and from there a square is equal to 2 y square. From there y is equal to a by root 2. So y is the displacement. You want to find out the y there. That means at what distance from the mean position. If a wave is moving, oscillation is done from the mean position, this is y. At what distance? Let this be y. We don't know. That is half root 2. Root 2 is equal to 1.7, right? 1.414. So you will get around that particular direction, at that particular distance, you will get a conclusion that kinetic energy is equal to potential energy. That means A means a maximum amplitude. Amplitude divided by root 2, or A divided by 1.414. At that value, at that particular value, you will get kinetic energy is equal to potential energy. So this is the first sub question. Now the second sub question, you just read, that is at what point is its speed half the maximum speed? That means for a simple harmonic motion, what is the point? At what point is its speed half the maximum speed? So it is about the speed. First one was regarding the position. Now it is about the speed. So from the simple harmonic motion, you know that velocity is equal to omega root a square minus y square. One plus and minus is there, but we are not dealing with that, because in this session, in this question, we don't want to get into that particular thing. Okay, so sorry, v is equal to omega root a square minus y square. So from the clue itself, we want to identify this thing. You have to, from the each questions there will be a hidden clue, or they will give something, some key points. You want to catch those things and solve that thing. So you want to find out at what point omega a square minus y square whole root will be equal to V max divided by 2. V max divided by 2. So whenever you see V max, you want to this particular equation. Okay, that is V max is equal to omega a. V max is equal to plus or minus is there. So omega a is the thing. So how this question? So V max is equal to omega a. So from here, you are just taking this thing, that is omega root a square minus y square will be equal to what? Omega a by 2. Omega a by 2. From there I am squaring those things to get rid of this square root. So omega square into a square minus y square is equal to omega square a square by 4. From there omega square cancel, and from here a small rearrangement should be done. So from you will get a square minus a square by 4 will be equal to y square, So from there you will get an equation, that is y square is equal to 3a square by 4. That implies what? That implies y is equal to what? Root 3 a by 2. You just take the root and you will get root 3 a by 2. So this is your equation, or this is your answer. That is, at what point is its speed half the maximum speed. So there y is equal to root 3 a by 2. So root 3 by 2 times the correct amplitude or the maximum amplitude. At that particular point, your speed will be half the maximum speed. Okay, so this is about your third question. Okay, heat engine is a device which convert heat energy into mechanical energy. Name the process in Carnot cycle. And the second sub question, can you design an engine of 100% efficiency? Justify. So here in the case of a Carnot cycle, 4 main processes are taking place there, and mainly 2, that is expansion and compression. But if in your exam, if you write these things, you will not get the marks. So in the expansion itself, 2 things are there. First one is isothermal and adiabatic. In the case of compression also, 2 are there. Same thing, isothermal compression and adiabatic compression. So 4 main processes are there. First one is isothermal expansion. Next comes adiabatic expansion. Third one is compression, that is isothermal compression. And the fourth one is adiabatic compression. So four major processes are taking place there: isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression. So these are the four processes that are taking place in the case of a Carnot's cycle. So now the second sub question: can you design an engine of 100% efficiency justify? In the case of a Carnot cycle, Carnot is stating that Carnot engine is the only engine which is having an efficiency 100%, and unfortunately it is not a practical engine because no other engines have 100% efficiency, and Carnot's engine is in fact an ideal case, and it is not at all possible also. Why? Because efficiency is given by 1 minus Q2 by Q1, right? 1 minus Q2 by Q1, and this Q2 will not be equal to, to become efficient, to make efficiency equal to 1, Q2 should be what? 0. Q2 should be 0, but Q2 will not be, at any cost Q2 will not be 0. That means always there will be a factor here, there will be an answer coming there, so that you will not get a 1. 1 means efficiency, 1 means 100% efficient engine. So this is not at all possible. This is not at all possible. So this is your justification for this particular question. So for the fifth question, consider a spring applied with a force within the elastic limit. First question, that is, draw the variation of force F with the displacement X from the mean position. Second sub question, what does the area of the graph represent? So in the first sub question, there is no they haven't mentioned anything about the force, that is what is a restoring force or a deforming force, nothing they have mentioned. So you can directly go with the question, that is, you know that F is directly proportional to X in the case of a spring. That is, when force applied, or if you are stretching a spring, obviously a restoring force will be increased there within the elastic limit. As a result, you can say that they are directly proportional, so you will get a straight line like this, that is EF, and X graph is plotted here, so you will get a straight line within the elastic limit, that is by Hooke's law. But if more precisely, you will get a different thing, that is, you want to consider the negative slope graph and all, but here the question is clear cut, no need of further overthinking and all. So you will get a straight graph there, that is, if you are plotting a force displacement graph, then obviously you will get a straight line. Why? Because they are directly proportional, there. And now the next question is that what does the area of the graph represent? Area of the graph itself, say F into X, if it is a straight line. If you are applying a constant force, I mean, if you are applying a constant force and moving a constant displacement, the area of the graph will be giving what? F into X, the force into displacement, that is what? Work done. So work done. And but here, what system is this? This is a spring system, right? So the work done on the spring, on this particular spring, will be stored as its what? Potential energy. So more precisely, you can say it will give you what? The potential energy. There. So the area of the graph represents the potential energy. So that's it.